Hello? Yes, class. Am I audible to all of you?
Yes, ma'am.
Okay, class. So in the last class, we had started with the comparison of electrostatics and magnetostatics. So difference between electric charges we had seen, difference between electric dipoles, magnetic field, equatorial point, axial point, these differences, then torque and work done. I have told you you have questions on torque and this SHM part also we had covered, then this basic question also. Now, we have to start there are certain terms which are related to magnetism, and these are very confusing. You will have the term magnet in every term. So what we'll just segregate all the terms and study it separately. These certain terms we did initially, remember magnetic axis, magnetic equator, like these. Now, these terms which are left, these are magnetizing field, magnetic induction, magnetic field intensity, intensity of magnetization, and magnetic permeability, relative permeability, and magnetic susceptibility. This is a relation, but till magnetic susceptibility, these are different terms. All of them have the same type of name, so be careful while listening, understand it. See, magnetizing field means what? Magnetizing field means in vacuum, whatever is the magnetic field which induces magnetism. For example, I have taken a magnet. So there are certain fields which are crossing it. So magnetizing field means magnetic field in vacuum. All right, magnetic field in vacuum. And this further induces magnetism. This further induces magnetism. Now, how is this possible? One example of this is you can,
Ma'am,
yes,
join now. Can you just repeat?
yes, I'll repeat on that. See, we are now studying certain terms. In the last class also, we have studied certain terms. Right now, what I have done, there are very confusing terms. If we study those together, no, along with the previous one, it becomes very confusing because all these terms, no, by the name, it will be so confusing to you because you'll have to give it a 2 or 3 readings at least minimum to remember it, to recognize it. Because all the time, usually what do we do? How do we remember the terms? We just see the word, analyze its meaning, and remember it. If I tell you what is magnetizing field, a field that can produce magnetism, this will come to your mind. Yes. If I say magnetic intensity, you will see intensity of magnetic field. If I say intensity of magnetization, you will say that is also intensity of magnetic field. So by the terms we are habituated to describe the meaning, right? Like magnetic axis of magnet. But there are certain terms which are misnomer. They have misleading meanings. Like intensity of magnetization is a separate term. Magnetic intensity is a separate term. So that's why I have made this as a separate heading. Some terms used to describe magnetism, because every term here is very confusing by its name. So don't go by the name here. That's what I'm trying to tell you. You can go by the name, work done, potential energy. All these terms you can see. The terms which we did earlier, these one. See, like directive property. So what comes to your mind? Directive property is related to direction of the magnet. So immediately in your mind, this can come that the magnet's direction is from north to south. Yes, like this. Monopoles do not exist. Or a term, magnetic induction, or what, like these terms, magnetic polarity. So poles of the magnet, you can remember and learn it like this, you will not forget it. Magnetic axis of the magnet, that also you remember it. Equator, magnetic length, What is the magnetic length? Means the entire length of the magnet. So these terms are not difficult. Even without revising, just by looking at the ring, you will all be able to manage them in your exam. These terms, which I'm going to do it today, these terms are little confusing. That's why I didn't do it in the last class. Now, first term is magnetizing field. This is different from magnetic. Magnetic field means a space where magnetic properties can be experienced. Magnetic field lines are present. That is known as a magnetizing field. That is known as a magnetic field. So this is different from magnetic field. This is magnetizing field. These terms, these are not very helpful for your separate questions of exam because these won't come. These usually do not come. These are very less important in that aspect. Separate question. But in the question, it can be mentioned. So you should just have an idea. Among these, some terms are very important that I'll mention. Now, magnetic field which is present in vacuum, air or vacuum, in that medium. See, different media are present. For different media, you have a different field. Magnetic field also existed for different media. Similarly, magnetizing field also exists for different media. So magnetic field which is present in vacuum, that we term as separately as magnetizing. So whenever magnetizing field is given, you can segregate it from the term magnetic field. Now, this further induces magnetism. For example, if you take the example of a solenoid which is kept in vacuum. If this solenoid is kept in a magnetic field, that field will be called as a magnetic field, which we have been studying. But if the solenoid is kept in vacuum, and now this is inducing magnetism, right? If this solenoid, this is now kept in vacuum, you can shift the media all the time. You can take the medium as air, you can take the medium as water, you can take all the medium. You know, for different medium, there are different presence of magnetic fields. What have we studied? We have studied the concept of permeability. In our Biot-Savart's law, we have the formula mu naught by 4 pi. Then we further have ideal sine theta divided by r square. But here we have permeability. This is directly linked with magnetic fields. You take the medium as air, your magnetic field will be the highest. You take the medium as water, you will feel magnetic field decreases. You take medium oil, magnetic field decreases further. Like this. Take, if you somewhere get, if you are having magnets at home or you are able to arrange them, try this. Dip the magnets in water. See, are they able to exert the exact property or not? Air, we know, we already know regarding air. Fine. So this is why we have to pay attention to this. So suppose a solenoid is present. A solenoid, I have taken it in air. Now I have removed air also. Complete vacuum I have taken. So still this will be, the formula will remain B is equal to mu naught Ni. Now this magnetic field, no, which we were earlier calling this as magnetic field. Now we'll call this as magnetizing. That is what is meant by magnetizing. Fine. So magnetic field basically in vacuum which induces magnetism. Means magnetic properties which are felt in air, those are exactly exerted. Inducing magnetism is being induced. That's why I'm continuously saying these terms are very confusing because they are misnomers. That whatever is the heading is not the answer what you will be studying. Induces magnetism. We should have magnetic induction as the term, but we have magnetizing. Magnetic induction is separate. See, magnetic induction basically means number of magnetic field lines of force crossing per unit area. Magnetic induction, one meaning you can refer to as, it can induce magnetism. It has a tendency to induce magnetism. But I'll suggest you to remember magnetic induction. This you should remember it as magnetic force. This you should remember it as magnetic force. Now this will become easier. See, how can you relate it with magnetic force, magnetic induction? Total number of magnetic field lines of force. Which force? This force is the magnetic force. So total number of magnetic field lines of force crossing per unit area. Had it been only, it's similar to flux. We have studied, no? In Gauss theorem, we have studied flux. So in Gauss theorem, we had studied regarding electric flux. Though magnetic flux will come again. In today's class only, most probably it will come again. Electric flux. So what did we study? If suppose this is a material present, these are number of field lines which are crossing per unit area, and this angle that is made, this is 90 degrees. So we count this as 1, we'll count this as second, so flux will be 2. Like this. This is very much similar to it. Magnetic induction. Total number of magnetic field lines of force crossing per unit area normally means making an angle of 90 degrees, is called magnetic induction. Suppose this is a wire. Now, among this wire, some magnetic field lines are flowing like this, and some magnetic field lines are flowing like this. Because magnetic field lines, there are different magnetic field lines of forces which are existing in nature. So only these field lines which are making angle of 90 degree, that is normally these per unit area, per unit the cross-sectional area. Which area you will consider? This area. This area. So per unit cross-sectional area. This gives you the magnetic induction. Fine. For these, we have, for every magnetic field, we have different terms. So total number of field lines of force, these are magnetic forces field lines. So we had electric field line, no? How to represent, pictorial representation of electric field lines. Suppose similarly, we have magnetic field lines also. So those crossing per unit area, making an angle of 90 degrees, called magnetic induction. Magnetic induction, I think we did earlier also, but we just saw the basic meaning of it, that how it induces magnetism. Property to induce magnetism is in magnetic substances. This we only do as magnetic induction. So proper broader meaning is this. Both meaning are correct, but just a broader meaning is this. This further induces magnetism. This further induces magnetism. Now, what did we do in the last class? We just studied this meaning only. So it has a broader meaning. This entire meaning is clear. Now, next topic is magnetic field intensity. Now, magnetic field intensity is what? These two terms, no, upcoming two terms, these are very, very confusing. Magnetic field intensity and intensity of magnetization. If you just hear the name, what do you think? Both are intensities of magnetic field. Apart from this, we cannot make out anything different. But both have different meanings and they are related to each other. Understand magnetic field intensity, intensity of magnetization is easier. Now, magnetic field intensity means what? It means ability to magnetize a material. Fine. Now, this is similar to magnetic induction also. That also induces magnetism. Difference lies in their calculation part. Physically, both have the same meaning. You can use magnetic field intensities, magnetizing materials. You can use the term magnetic induction is magnetizing materials. Both are same, but their mathematical calculations are different. So mathematically, they both are totally different because magnetic induction is number of field lines divided by area. Field lines of force divided by area will give you magnetic induction. But when we come to magnetic field intensity is related to current. It's, see, magnetic field intensity, we represented by the symbol H. Now this is ampere turns flowing around the unit length of solenoid. I told you, no, this we talked about, the perpendicular ones. What about these, which are wrapping the wire, which are wrapping your solenoid? Suppose if we take a solenoid, if we take a wire, this which is flowing, these, This we discussed. These are magnetic induction. What about these which are flowing round the length of it? So for these, we have magnetic field intensity. This is how we differentiate magnetic field intensity and magnetic induction. So it is the ability to magnetize a material. So ampere turns means the current that is flowing around the unit length of solid. Now, Ni we will take for the number of turns, I as the current. N is number of turns, I is the current. Now, when we talk about solenoid, because we commonly refer to solenoid as a standardized material for our magnetic field calculations. Because in solenoid, perpendicular fields also run. There are field lines which are running around the circle also, its length. So that's why we talk about solenoid in particular. So when I say no, B is equal to mu naught Ni, from here, this formula is used in the calculations also class. This is important. Magnetic field intensity, intensity of magnetization, these are important. Ni, I can write Ni as H. So this becomes B is equal to mu naught H. So what is the intensity of magnetization? H is magnetic field divided by permeability. This is the formula. Intensity of magnetization, I'll tell you once you note down these three will become clear, then I'll go further. Example 4.2 NCRT table. Okay, that I'll discuss. First, note down this one.
Okay, school.
See class, done till here? Say intensity of magnetization is the second term that we have to study. Intensity of magnetization means, don't go by the name that it is intensity of the magnetic field. This I have told you clearly that all the terms are different, the names are also different. This is ability to magnetize a material. Intensity didn't play a role over here as well. Intensity of magnetization, this is very different. We have studied magnetic moment. This is magnetic moment per unit volume. P represented by capital M. So magnetic moment, magnetic dipole moment, this means the same, divided by volume. This is magnetic moment. So it's more of magnetic moment density rather than intensity of magnetization. But the name is intensity of magnetization, and this name will be used as it is in your calculations. You'll be given certain data like current will be given to you, area of cross section will be given to you, volume will be given to you. So you can multiply these to get magnetic moment. You can divide these to get the intensity of magnetization. So like this, numericals can also be made based upon this. So, and this is volume. This is volume. Magnetic moment is the same. Yes, I, number of turns are given. So N, I, A. This is it. All right. So magnetization, this is more related to the strength of the pole. If we talk about it, this is mathematically. But when we talk about it, this is this term of the magnetization it is talking about. This is more of the pole strength. That is the strength of the poles, North Pole and South Pole. This is much related to this. If we talk about its physical name, mathematically is this. And one more thing, see, total magnetic field will now be what? Magnetic field. If we talk about the total magnetic field, this is magnetic field due to, means total magnetic field will be intensity of magnetization plus magnetic field intensity. So we write this sometimes as mu m. And this already I've told you this is mu h. So somewhere you will be requiring this formula also. Mu not take it as common, m plus h. This more than numerical, this comes what is the relation between intensity of magnetization and magnetic field intensity. Then you just have to show these steps. Intensity of magnetization and magnetic field intensity. Fine. Now the next two terms are very easy. Magnetic permeability, this we have already done. Magnetic permeability, this is similar to relative permeability, to electric permittivity also. Magnetic permeability, when we talk about simply when we talk about magnetic permeability, that means I have told you how the different material are providing magnetism in different media. Yes. So this is magnetic induction divided by magnetic intensity. Magnetic induction by magnetic intensity. This is the formula. So I've already told you these are very confusing. Please revise today itself. After the class, no, revise and complete. And this is magnetic intensity. And relative permeability, this also we have studied. What is relative permeability? Relative permeability is mu divided by mu r. That is permeability in a medium. Permeability in a medium. And this is permeability in air. What is permeability in a medium? This is absolute permeability. And when you compare it with the permeability of air, that becomes relative permeability. That's it, right? Relative permeability, this we have already studied. One last, this is that, no, magnetic susceptibility and its relation with it. Note down till here, then I'll discuss the last one. Done till here? Till relative permeability, whatever, whoever didn't complete it. See, magnetic susceptibility, when we talk about magnetic susceptibility, it's the ratio of intensity of magnetization to magnetic field intensity. Magnetic susceptibility, we have a symbol. This is similar to X. We call this as chi. So we write it as chi m for magnetic susceptibility. So magnetic susceptibility is intensity of magnetization to magnetic field intensity. This is the ratio which gives you magnetic susceptibility. Intensity of magnetization by magnetizing field intensity. See, when we talk about the units of magnetic susceptibility, intensity of magnetization is current per unit area. And this SI unit is also current per unit area. Whenever we didn't talk about the SI units, no, intensity of magnetization and magnetizing field intensity. So SI unit, when we talk about for magnetic susceptibility, for intensity of magnetization, this is ampere per meter square. For magnetizing field intensity, this is ampere per meter square. So this gets cancelled and you have no unit. So remember, it is a unitless quantity. It is a unitless quantity. And when we talk about the dimensions, it has dimensions. Dimensions are present. Because the dimensions, when we write the dimensions, it doesn't become zero. So it's a unitless quantity, but you don't need to learn about the dimensions. This is magnetic susceptibility. See, there is a relation also which you have to remember between mu naught and chi m. This relation comes as a derivation. This is important. This comes as a derivation as a separate 3-marker also. Magnetic field is what? This is mu naught H plus M. Yes, we have seen this. What is magnetic? If we talk about intensity of magnetization, this is V is equal to mu H. So if I equate both of these, I get mu H is equal to mu naught H plus M. Yes. So do one thing, divide the entire equation by H. So when you divide it by H, this becomes mu H by H. This is mu naught H plus M. This becomes divided by H. This is divided by H. So what are we left with? Mu is equal to mu naught 1 plus M by H. And what did I tell you? What is M by H? Intensity of magnetization and magnetic field intensity. It is chi and magnetic susceptibility. So final equation mu, the relation which you have to remember also. Mu is equal to mu naught 1 plus chi. This relation comes often to derive. Numericals usually do not come. I have told you from this topic, no, numericals usually do not come. You have the terms. Remember the terms wherever they are used. These are very confusing terms. The headings are different. The content inside is different. Ratios are also different. Formulas are also very different. So revise this today itself because this will be very confusing. Quickly note it down. Then we have to do types of magnetic substances. Paramagnetism. For this, I'll share a table also on the group. There you'll find everything written. On WhatsApp group only I'll share. From there you can learn that table and everything will be done from it itself. But I'll discuss this once. First note it down. Now we'll classify the magnetic materials into 3 categories. So these are written in short, though I have shared a table with you on WhatsApp. Everyone, just tell me, have you received that? Just check your WhatsApp. I have shared a table with all of you. Only Austin received. Nobody else
Yes, Miss,
has
got it.
received. Madiha, Tarif, Prabha, Shahid, Chavez.
Yes, Miss, got it.
Okay.
Yes,
So is there anyone who hasn't received it? Received, no? Okay. So if you all have received, then fine. Just open up that table also when you are okay, Shahid. Okay. Okay, good, good. If you have received. See, we'll classify the materials as diamagnetic substances, then we have paramagnetic substances and ferromagnetic substances. So basic properties I'll discuss in the class because these you have to learn by yourself in any ways. Now see, feeble, what I'm telling you is the terms which will be coming in that table also. Diamagnetic substances have feeble magnetization. Feeble magnetization means weak magnetization. Let us discuss first diamagnetic substances, then rest of the substances we'll discuss. So diamagnetic substances have weak magnetization. And whatever is the direction of magnetic field, their magnetization will run in opposite direction. And feebly repelled by magnets. Third point, this means they are weakly repelled by magnets. If you bring them in magnet field that repel, they are feebly, weakly repelled by magnets. Now, where does the magnetic field line will travel? It will travel from stronger magnetic field lines to weaker magnetic field lines. These are weakly repelled by magnets. Second point is that where one section will be having higher magnetic field, second section will be having lower magnetic field. So from higher section of magnetic field, it will be traveling to lower section of magnetic field. It will be traveling from higher section of magnetic field to lower section of magnetic field. So this means tends to move from stronger to weaker parts of magnetic field. This is what is, these are the main points which I have written it. Rest you will find it in your table also. Uniform for non-uniform magnetic field, external field, all these. So substances, yes.
Ma'am,
Yes,
here
ma'am.
this line from strong B to small b, it's a magnetic field line.
Magnetic field, not field lines, the entire magnetic field.
Okay.
When we talk about magnetic field, so under, it's a broad umbrella. So under that magnetic field lines will also come. So when I say it tends to move from stronger to weaker parts of magnetic field, we are talking about the magnetic field lines will tend to move from stronger to weaker part of magnetic field. This you're asking, no? This is correct. In
Yes.
diamagnetic substances, yes, that you're right. Magnetic field lines will tend to move from stronger to weaker parts of magnetic field. We have the broader aspect as magnetic field. There we'll be having some region which will be located closer to each other. That will be depicting a stronger magnetic field. Then some region will be present where magnetic field lines will be far apart from each other. That will be depicting weaker field lines. So it tends to move from stronger to weaker parts. This is a property of diamagnetic substances. Sometimes you have to identify, and most of the case this is a very important topic, types of magnetic material. This will come in your exam as a separate question. You have to write the theory. Sometimes differences between all the 3 materials come. Sometimes between 2 materials come, like differentiate between paramagnetic and ferromagnetic, differentiate between diamagnetic and ferromagnetic, like this. So paramagnetic substances, they also have feeble magnetization. Feeble magnetization means weak magnetization. And the difference between diamagnetic and paramagnetic substances is that it travels in the same direction to magnetic field. Diamagnetic substances, the magnetization, it traveled in opposite direction. Here it travels in the same direction of magnetic field. This is what you have to remember. Fine. Feeble magnetization is there, this magnetization. This is actually one complete sentence if you read feeble magnetization in same direction to magnetic field. But feeble magnetization is also one point of difference, and direction of magnetic field is also one point of difference. That's why we study it differently. Now, feebly repelled by magnets was the point of diamagnetic substances. This is feebly attracted by magnets. Means If you bring a different magnet near the vicinity of a paramagnetic substance, there will be forces of attraction, but the strength will be very less, weaker attraction, weaker attractive forces. And they also tend to move from weaker parts. They move from weaker parts to the stronger parts. This is the difference that comes. So NaCl, copper chloride, you can just remember the names of one or two substances. Just remember in such a way that if a differentiate question comes, substances will not be given to you from where you have to identify. What you have to remember, just remember one or two substances, because if it comes in differences, so in differences, you will have to mention one or two compounds. Then only, if we write the examples at the end, then only marks will be given. Last is ferromagnetic substance. What is a ferromagnetic substance? It has a strong magnetization. So this is completely different. Paramagnetic, diamagnetic, they had weaker, feeble magnetization. Now ferromagnetic substances have stronger magnetization. And this point is same in the same direction to magnetic field. So strong magnetization in the same direction to magnetic field. They also show attractive property when magnets are brought near it, and they are strongly attracted by it. And again, they also tend to move from weaker to stronger parts. So certain examples, you have iron, copper, nickel, all the alloys. Alnico is one alloy, which we write. This iron, copper, and cobalt and nickel. Iron, nickel, and cobalt. This is also one example which we write. Do one thing, note down this in tabular form. Rest table I have given to you, then I'll discuss the rest of the thing. Just write down it in tabular form. I'll just make it shorter so that you are able to write all the three together. Text me done once you have completed till here. All right, all those who have completed, you can leave. Please attempt your after class assessment today. We'll continue tomorrow. We'll finish off with this lesson. Now, Earth magnetism is left. Most probably, we'll start a new lesson also tomorrow. Earth magnetism and some laws are there, like Gauss law in magnetism. Some portions of magnetism are there, and mainly Earth magnetism. So it's a small topic that we'll complete tomorrow itself only. Now, please revise that table and come. All right, I have shared a table, revise that come. And regarding the question you were mentioning, someone mentioned Rabba. Yes, Rabba, that question also I'll discuss tomorrow. And right now I have seen Chavez at center question while sending it. That was missed by me. That's why I couldn't see. Chavez, that also I'll discuss it tomorrow. Or I'll share it on WhatsApp, both the answers. Which you are mentioning also, Rabba. Example, which 4.2 NCRT. This is in text question, Rabba.
No, ma'am, it's example question. The
That
answer is
is
given, but I can't understand how we get the answer. It's
This
about
is
that.
in text example.
Yes, ma'am.
Rabba, can you just click the pic and share it on the group?
Yes, ma'am.
That would be better. Okay. Thank you so much.